Hi everyone, so glad that you once again made it to today's lesson. Today we are looking at grade 11 revision. We are looking at trigonometry, what we call part 2. This is where we're going to start looking at 2D trig. The last time we looked at all of the other sections that are involved with trig equations, trig graphs, identities, and reduction formulas. So today we're looking at 2D trig, which is now the spatial concept of trigonometry. It's a really exciting section in trigonometry because this is where you get to apply all of the other things you learned from trigonometry before this. All right, so some of the things that you need to remember, just a summary of some of the rules. You worked with the sine, cos, and area rules. And remember that the area rule you would use in a triangle with no 90 degree. So the area of triangle ABC is a half BC sine of angle A if you're given angle A. If you were given a different angle, then your formula will change accordingly. What is important here is that to work out the area of a triangle, you need the included angle between the sides that you are working with. So if we look at triangle ABC and I've got side B and C, then my area for this triangle, if I've got side BC and angle A, would be a half B times C sine of angle A. All right? The sine rule, we use this formula, sine A over A, little a being your side, is equal to sine B over B is equal to sine of angle C over C. And of course, we can take the reciprocal of those so that we get A over sine A is equal to B over sine B is equal to C over sine of angle C. Again, working with the same triangle, and depending on what you've been given, you'd be able to work out the lengths of the sides and the angles that you need using the sine rule. So say you were given side B and side C. The angle, though, must not be the included angle. So you need to have been given, so say we're working with B and C, and those are the ones that you know, the angle needs to be some other angle that you were given, not the included one, so that you know that you can use the sine rule. But we'll talk more about when you use each of these rules in just a little bit. The cosine rule, you've been given two sides and an included angle, and this will help you to find the length of the side depending on what information you've been given. Very importantly with trigonometry is not to round your answers off too quickly. So what we like to do is to keep the answer in the memory of the calculator and then only right at the end round your answer off. The reason for this is because obviously if you round off too soon, it will affect the accuracy and the number of decimal points you are using. So always try to do the calculation in one complete step and only round off the final answer. So when do we use the area rule? Now remember, we learned long ago that the area of a triangle is half base times height. But what happens if you don't have a height that's given? This formula only works when you've got a 90-degree triangle. So in any other triangle, you use the area rule. And to use the area rule, you need two sides and an included angle. When do we use the sine rule? Once again, you eliminate no right angle. So remember, when you've got right angles in triangles, then you can use those trig ratios. You can say cos of theta is equal to adjacent over hypotenuse, sine of theta opposite over hypotenuse, tan of theta opposite over adjacent, and you can use that to solve the triangle. So that is when a right angle is given. When no right angle is given, then we use the sine rule. So generally you will use the sine rule when you've got two sides and an angle that are given, but not the included angle, so as I showed you on the diagram before, or if you've been given two angles and a side, you will use the sine rule to help you solve the triangle. The cos rule, once again, you take out the right angle. If there's a right angle, we can do things in a quicker way, but if there's no right angle, we can use the cos rule if we've got two sides and an included angle, or we can certainly work out the angles if we are given all three sides. All right. An important concept that you learned in grade 10 is the idea of angles of elevation and depression. Now remember, when you look up or if you look down, your eyes do not drop to the floor or just rise up in your head to the ceiling. it's always taken, the angle at which you look at an object either up or down is taken as the angle between the horizontal and the line of sight. So the angle of elevation, so that's when you're looking up, is the angle between the horizontal and the line of sight. Okay, so we call that the line of sight when you look up. The angle of depression, so if we're looking down, is the angle between the horizontal and your line of sight. So if we look at a diagram, so if I'm looking up, my angle of elevation here, this theta here, we look in the direction upwards, and then the angle between the horizontal and the line of sight would be my angle of elevation. And then if I'm looking down, the angle of depression is taken as the angle between the horizontal and the line of sight. That's important because depending on what your question says to you, sometimes you may even need to draw a diagram. It's important to understand that these angles of elevation and depression are always measured with the horizontal and the line of sight as the adjacent sides of the angle. All right, let's look at example 1. Obviously with trig, we said what's really exciting is it's all about application. So we cannot just talk about trig, we have to do some trig. They say that a boat is sailing directly towards the foot of a cliff. The angle of elevation of a point on top of the cliff and directly ahead of the boat increases from 9 to 13 degrees as the boat sails 120 meters towards the cliff. Now, as you can see, if you haven't been given a drawing, it's really difficult to know where to start. But in this case, we've been given a drawing, so it's really nice. We can work through it. But if you haven't been given a drawing, let's just make a quick drawing here. We've got a cliff. We know that there's a little boat that's sailing towards the cliff. They tell us that there's angles that are increasing. All right. So we've got that. There's the boat there. There's my cliff. And there's my angle. So something like that. Obviously, this is not an accurate sketch of what's happening. My little triangle doesn't quite look like a triangle, but it's supposed to be a triangle. The important thing when you're looking at these two-dimensional trig questions is to remember that all your information that you are given can be broken down and can be put into single triangles, and then you can transfer information from one triangle to the other. A cliff will always be at 90 degrees to the ground. It will be perpendicular to the ground. Okay, so that's sort of what we're looking at. The boat has moved 120 meters before the angle changes. So this is what the diagram really looks like, and a much neater sketch than what I drew. We can see that the angle increases from 9 degrees to 13 degrees. AD is the cliff, and the angle of elevation from point C is 9 degrees when I look up to the point on the top of the cliff, and the angle of elevation from B to the top of the cliff is 13 degrees. When I have a question like this, I can see that I'm going to need angles in triangle ABC, this one. So what I like to quickly do is to work out a few angles. I can see that angle A1 is going to be 4 degrees because exterior angle is equal to the sum of the interior opposite. So this is going to be 4. And then angles in a straight line, I'd be able to work out angle B. We've got a length inside given of side BC, which is the distance that the boat has traveled so far, and it's traveled 120 meters. Okay, so that's our sketch. We've now analyzed the drawing. Let's answer the question. Let's see what the first question says. Determine the original distance from the boat to a point on top of the cliff. So we're looking from here, and they're saying you're going up like that. What is that distance AC? That's what we're looking for. Now let's look at what information we've got. We've got angle C, right? We've got side BC. Do we have other angles? We've got plenty of other angles. In fact, we know all the angles in triangle ABC. So I've got more than 2 angles and a side in triangle ABC. That tells me I'm going to be using the sine rule. Okay, so how do we use the sine rule? Let's set that up quickly. We're going to say AC over sine of angle B1, which is sine of 167 degrees using angles on a straight line, is equal to 120 degrees over sine of It's not 120 degrees, sorry, it's 120 meters over sine of 4 degrees. Okay, once we've got our equation for the sine formula set up, we can find AC by simply cross multiplying, or we can just simply multiply the sine 167 multiplied by sine 167 on both sides. On this side, on the left-hand side, of course, it cancels. On the right-hand side, we end up with 120 times sine of 167 degrees all over sine 4 degrees. You put all of that into your calculator, and you end up with 386.98. I just had to look back at the question because I wanted to see if it said anything about rounding off to 2 decimal places or 1 decimal place. It did not say. In this case, we've chosen to round off to 2 decimal places. So if you enter all of this into your calculator, which we can do, but it's not necessary, you simply enter all of this into your calculator, round off to 2 decimal places, and we get that the length of AC, which is the point, the original point, if we look up to the cliff, that's the distance from the boat, looking up to the highest point on the cliff, and therefore we get 386.98 as the original distance from the boat to a point on top of the cliff. The next question says find the height of the cliff, so that means they want us to work out side AD. Now I see that side AD folds in more than one triangle. Remember to keep in mind that you've just worked out this side AC. So you will likely use the side that you've just worked out. Don't now try and go into triangle ABD because you're going to have to work out and do more working to find the side AB. So I can say because there's a 90 degree, remember I said first look and see if there's a 90 degree because that's going to make life easier. I can see that opposite the 90 degrees is side AD, so that's opposite, and I've just worked out the hypotenuse. So sine of 9 degrees will be opposite over AC, which we've just worked out, and by simply cross multiplying or by finding an LCD of AC or timesing both sides by AC, we are able to work out the length of AD. So AD would be 386.98 times sine of 9 degrees, working from the fact that sine of 9 degrees was equal to AD, which is the one we're looking for, over AC. So therefore AD would be equal to AC times sine of 9 degrees, and that gives us the height of the cliff as 60.54 meters. Okay guys, let's take a quick break while we think about this example and think about what we learned here. When we come back, we'll have a look at doing a little bit more revision on 2D trigonometry. We're back after this. Hi everyone, welcome back. We are looking at two-dimensional trigonometry and grade 11s. What we are revising is just some of the concepts and rules you've got to apply when you are dealing with these types of questions. We've already revised the sine rule, the cos rule, and the area rule, and just reminded ourselves when we need to use each of those rules. Remember, when you are working with 2D trig, we always want to isolate down to a single triangle and then transfer information between triangles where more than 2 triangles exist in the question. Okay, let's look at example 2. So you're told here that in triangle ABC, AC is 2 times the length of AB. And we can see that AB was given as T, so therefore AC will be 2 times that, which is 2T. You then have that AF is equal to BF. So AF is equal to BF, and that's been marked as N on your diagram. Angle AFB is equal to alpha, and FC, side FC, is 2 times side AF. So therefore, remember we said AF was equal to N. We've just used random variables, and therefore FC is 2N. You are asked to prove that cos of alpha is equal to a quarter. Now, what is a little bit tricky in this question is it doesn't fall into the format that you are used to. you're not quite sure where to start with this type of question because there's so much of information given and you've just got to prove that cos of alpha is equal to some ratio. So it can be overwhelming at times, but remember guys to follow the rules that you know. All you can do is apply the rules you know. And what you know is that you need to work in individual triangles and transfer information between them to see if you can somehow get this ratio out. Okay, so what I'm going to do is I'm going to work in triangle ABF and I'm going to work in triangle AFC because we've got plenty of information there and I see that we've got common variables between those triangles, so certainly a substitution is possible within this question. Okay, I've been given sides in triangle ABF. I've got three sides and an angle. So I've got the included angle and two sides. That tells me I'm leaning towards the cos rule. If I look at triangle AFC, I've got three sides. Once again telling me I'm probably going to use the cos rule, but also I've got an angle. Which angle do I have? Well, I know using angles on a straight line that angle AFC is going to be 180 degrees minus alpha. Okay, so let's start. We're going to work in triangle ABF firstly. And we said, well, in triangle ABF, we've got all three sides and we've got the included angle AFB. So I can set up this. I can say, well, side t squared using the cos rule will be equal to n squared plus n squared minus 2 times n. This is just a straightforward application of the formula cos of the included angle. Okay, and then we're going to do a little bit of simplification here. So we end up with 2n squared minus 2n squared cos alpha is equal to t squared. Please do not be tempted to say 2n squared minus 2n squared cancels. You cannot do that. Remember that you are not cancelling like terms here. This 2n squared is attached to the cos alpha. So it's almost like saying x, y, and then you've got an x by itself. These two terms are not the same. So you cannot cancel the 2n squared and the negative 2n squared. All right? So we're simply going to have t squared is equal to 2n squared minus, I'm just going to rewrite it, 2n squared cos alpha. Okay, and because the question had this, this ratio cos of alpha is equal to a quarter, I'm thinking, well, let's try and get as close to cos of alpha as possible. So I'm going to just isolate the cos alpha by changing the subject of the formula and moving the other terms away from the cos of alpha. So you're isolating the cos of alpha. All right, so how do we do that? Well, we're going to say, well, cos of alpha, if I take minus 2n squared to the left-hand side, I get positive 2n squared cos alpha. At the same time, I'm going to bring this t squared over to the right-hand side. So I get 2n squared minus t squared. And then I'm going to divide through by 2n squared. So I get cos of alpha is equal to 2n squared divided by 2n squared is 1. And then minus t squared divided by 2n squared is minus t squared over 2n squared. So as you can see, we've got to a cos of alpha in triangle ABF. Next, we're going to work in triangle AFC. And because I've got this angle F here, I could perhaps think, well, perhaps let me use the cos rule and work out my sides. So I could say, okay, well, cos of angle F or AFC is equal to, and then do that whole formula. So let's see how it works. Let's see what we decide to do here. So I'm going to set up my cos rule again, saying that in triangle AFC, 2t squared, remember to use your brackets so that you remember to square the 2, is going to be equal to n squared plus 2n squared And we've got cos of 180 minus alpha. It's n squared plus 2n squared minus 2 times 2n squared, not a square there, sorry, 2 times 2n times n cos of 180 degrees minus alpha. Okay, and let's do a little bit of simplifying. So we end up with 4t squared is equal to 4n squared plus n squared gives me 5n squared minus 2 times 2 is 4 times n is 4n squared. Now look at this cos of 180 degrees minus alpha. That's now using reduction formula. This is why I said this is a nice section. It combines everything we've learned so far. I remember that cos of 180 minus alpha is negative in the second quadrant. So I end up with negative cos alpha. All right, so we get 4t squared is equal to 5n squared minus times a minus is a plus, so it's actually plus 4n squared cos alpha. All right, and then if we isolate the t squared by dividing through by the 4, we end up with t squared is equal to 5 over 4n squared plus n squared cos alpha. So I've got this equation, which I'm going to call equation 2. And then before, we saw that cos of alpha was equal to 1 minus t squared over 2n squared, which you can call equation 1. And basically what we're seeing, guys, is that there's this t squared that we've got an expression for. And because I've got cos alpha in the first equation, if I replace t squared with the expression I just found, that means that potentially I can work towards eliminating the variable n and then getting that cos of alpha is equal to a quarter. So all I'm going to do is where I saw t squared in equation 1, I'm going to replace it with this expression that I just found. Okay, so therefore, as we said, we're simply going to replace. There we go. Here we've just swapped the equations around and called the t squared equation equation 1 and the cos alpha equation 2. It doesn't matter as long as you do the correct substitution. So you end up with cos of alpha is equal to 1 minus t squared was 5 over 4n squared plus n squared cos of alpha all over 2n squared. Does this give you a quarter? Well, let's see. Now you've got to do a little bit of work. We've got to simplify this a little bit. So you can times your minus n, or you can certainly divide through by your common factor of n squared. And in fact, let's do that. So this is equal to 1 minus, if we divide through, so I've taken a common factor out. I haven't crossed out the n squares across a plus sign. So you take your n squared out as a common factor. And this is really good. And if this is as far as you can get, then you have already gotten pretty far by yourselves, because from here it's just a matter of algebra and simplifying. So the n squareds cancel and we end up with 1 minus 5 over 4 plus cos alpha all over 2. Okay, and what you can do now is you can now find an LCD, or you can simplify this whichever way you think would be best to work with your fractions here. So what we're going to do, and I'm going to need a bit more space, I'm going to move on to the next slide. We end up with cos. We are not quite done, guys, so let's just go back in there and move to our slide that we were looking for. All right, and this is as far as we've got. So cos of alpha is equal to and in fact, we are running out of time, so I'm going to leave this for you to finish. I just want to times this minus in and show you what you end up with. So we've got minus 5 over 4 minus cos alpha, and in fact, because we're timesing through by a half, it's going to be minus cos alpha over 2, and 5 over 8. All I've done with these terms is, remember, this was all over 2, so I've simply divided through by the 2. And when you times the minus in and subtract, and then bring your cos alpha over to the left-hand side, and I'll leave this algebra for you to do, you will see that it does work out, and you do, I promise you, end up with cos of alpha is equal to 1/4. Thank you so much for spending your time with us. Until next time, cheers.